A person going to a party was asked to bring 5 different bags of chips. Going to the store, she finds 17 varieties. How many different selections can she make? All right, so let's see if we can find a counting rule that works with this. Remember that we always want to first get organized and determine N, how many items are available to select from. You may need to list them out and count them if you're having trouble determining this. 2, determine R, which is the number of trials that will be performed. In other words, how many spaces are you going to fill? You might want to think about what one trial is. Consider the process that is going to take place and how many times it's going to be done. 3, determine if you're doing selections without replacement or if repetitions are allowed. So here we see that N is 17 because we are selecting from 17 different varieties of chips. And we will be bringing 5 only. So we have 5 spaces to fill. And we also want to know if we should allow repetitions or if we're doing this without replacement. Well, if these are my 5 bags of chips that I'm going to select, and let's say I choose barbecue, can I choose barbecue for all of them? Maybe I just like barbecue chips, so I'm going to bring 5 bags of barbecue chips to the party. Well, the hostess or host did ask for different bags. They want a variety for their party. So it wouldn't make sense to choose all of the same type or even choosing 2 bags of any one type. So we want them to all be different. So maybe we want barbecue, sour cream and chive, Cool Ranch Doritos, plain, and possibly salt and vinegar. That would make sense, right? So we're going to do these without replacement. Okay, now the next question is, does order matter? Order is always the next thing you want to ask because out of all the counting rules that we could choose from, and we have to determine which one makes sense, there's only one in which order does not matter. And here we'll say that it does not matter, which means that it could be combinations. And we just want to verify that we are doing this without replacement because that is a requirement for using the combinations formula. Okay, and we always like to consider this as a possibility first because if order doesn't matter, there's only one formula that might work as long as we're doing selections without replacement. And if order does matter, then we can cross this option off of our list of possibilities as we're trying to determine which counting rule we should use. So here we determine that order does not matter, which means our search is over. We can go ahead and use the combinations formula. The combinations formula is mathematically n factorial divided by n minus r factorial and divided by r factorial. So we know our n is 17 and we're going to select 5 bags of chips. So this is going to look like 17 factorial over n minus r. Well, 17 minus 5 is 12, and then r is 5. Okay, now what does the factorial mean? It means this little exclamation point here means shorthand for saying expand this and multiply all the way down to 1, right? All the way down to 1. But I have a 12 factorial in the denominator here. So it's convenient for me to only expand as far as the largest factorial in my denominator. Okay, and so this 12 factorial here is going to cancel out to 1. But I still have this 5 here, so I'm going to write that out. 5 times 4 times 3 times 2 and times 1, but you don't necessarily need the 1, but I'll leave it there anyways, just in case we end up with nothing else in our denominator. We always remember that there is a 1 always in the denominator. So now we can reduce. We can get rid of some things like 5 times 3 is 15, and I have a 15 in the numerator to cancel out. So that's gone. We have 4 times 2 is 8, and 8 into 16 is 2. So we'll go ahead and write a 2 down here, cross that off. Then we have only a 1 in the denominator at this point, so we're not going to be able to cancel anything. So what's remaining? I still have a 17 that I need to write in there, a 14, and a 13. Okay, so now that I have crossed everything off, I have a simplified version, and I'm going to just rewrite this as 2 times 17 times 14 times 13. Okay, so I can calculate that using one of my cells, like a regular calculator, standard calculator, equal sign first, then 2 times 17 times 14 times 13. So I'm getting 6,188. Also, I could use the combinations formula in Excel, the combine function, which is the word combine without the E at the end. Wants the total number to choose from, 17, comma, the number that we're going to select. So that's 5. And there you get the same answer doing it that way. All right, so the answer here, let's read again. Just be careful of whether it's asking you for a probability or if it's asking you for how many ways. In a similar problem, it asked us for the probability, so the answer was 1 divided by the number. But here, they're only asking us for how many, so the final answer is just the 6,188. Okay, so notice that our counting rules are very, very useful for getting us an answer quickly, and Excel can help us make sure that we're thinking correctly as well.